Hey there, it's Jason from Codemanship with a video about continuous integration and continuous delivery for C# developers. Now, whether you're working on a team or working by yourself, we've talked in previous videos about the importance of version control. Version control is essentially seatbelts for programmers. So you saw me in previous demos, for example, the demo I did on refactoring, sort of committing my code on a regular basis. And I also suggested that it would be a good idea to push that code to my Git repository on a pretty regular basis too, for a number of reasons. One of which was that I wanted to share those changes that I was making with the rest of the team on a frequent basis. Now, there are a lot of teams out there who are doing what we call continuous integration. As the name implies, it means that members of that team or people working on the same shared code base are frequently sharing their changes, checking their changes into a shared repository. And that means that essentially that they're checking their changes into the same branch in that repository. It's become fashionable, for example, for teams these days to work on their own branches, and that's absolutely fine, provided that those branches are being merged with the main branch, what we often refer to as the trunk, on a frequent basis. And there are three good reasons for this. Reason number one is we want to test that the changes we're making to the code don't conflict with changes that other people on the team are making. Now, the less often we check in our changes, the more potential there is for merge conflict. So teams, for example, who are only checking their changes in every few days or every week, tend to find that they're stuck in what we call merge hell a lot of the time, where there are all sorts of conflicting changes because they're checking in these changes in large batches. So all sorts of stuff has changed. So the more frequently we merge, the less changes there are in each of those merges each time we check in, and therefore the less potential there is for merge hell, for us to be spending a lot of our time fixing problems that didn't need to happen, really. So goal number one here of continuously integrating, of checking in our changes to the same shared branch, is to test that our changes work with other people's changes on a frequent basis so that we can avoid that merge hell. The second reason we do it is to communicate the changes we're making with the rest of the team. Again, the more changes we spring on the team in one go, the more potential there is for conflict. And I've worked on many teams where we've had that one person on the team who checked in their changes maybe once a fortnight, and it was a complete train wreck for the rest of the team. But it also meant that we had no visibility of what they were doing in terms of design. So very often we were, in terms of code reviews and fixing code smells and architectural problems, we were trying to shut the stable door after the horse has bolted, basically. It was often too late. So it's a way of essentially sharing what you're working on with the rest of the team. And I always recommend that developers become sort of build aware, in the sense that they keep an eye on the changes that are being checked in by other members of the team, and on a regular basis they pull those changes and merge them with their local code, and very importantly make a point of taking a look to see what the other developers have been working on. Too many developers, I think, seem blissfully unaware of what's going on with the rest of the team, but it's one code base, it's a single code base with all those dependencies and etc., etc. And one of the most common sources of duplication that I see in code is developers going off and working on their own parts, as it were, and then creating 2 customer classes or, 3 invoice tables and etc., etc., because no one was looking what anyone else was doing. And I've seen many code bases where essentially there are multiple different architectures. People, for example, have done model view controller in 4 or 5 different ways because they just weren't looking at what everyone else was doing. So for all those reasons, it's a good idea to check in your changes on a frequent basis so that the rest of the team can take a look. And if they need to, they can come over and have a chat with you, or these days they can Zoom you or Skype you and have a chat with you about the changes you've made, if there are any potential problems or things that need to be cleared up. So number one, it's a form of testing. Do my changes work with other people's changes? And the more frequently, as with unit testing, the more frequently we test, we tend to find the less hassle we get into, the shallower the holes we dig for ourselves. So it is a good thing. It's also a form of communication amongst the team, in the sense that it's a way of sharing what we're doing, what we're changing with the rest of the team, so they can If they're of a mind to, they can take a look, and if there are any potential conflicts or stuff that needs to be discussed, it gets discussed a lot earlier when it's a lot easier and cheaper to fix. And the third reason that we do it is this thing called continuous delivery. Now, a lot of people think continuous delivery means that we're continuously releasing or shipping the code. That's not necessarily what it means. What it means is that our code is continuously shippable. And the implication of that is that whatever we've got, it's in version control on the branch that we're going to use to build and release that product. Again, usually the trunk, the branch that everybody's ultimately merging to. So the implication of that, of course, is that the code needs to be in version control. It needs to be on that branch. And the way that it gets there is that we need to be frequently checking our changes in to make sure that they're there. It's no good to your business if they've spent thousands of pounds on software development, but it's all sitting on your desktop, or it's all sitting on your own private branch. That's of no use to the business. So to make it continuously shippable, it needs to be on the trunk, or it needs to be on the build and release branch, whatever you call that. And there are some technical implications here, of course. For the code to be shippable, that means it must work. And that's really what we're going to be talking about in this demonstration. How do we frequently check in our changes, merge our changes with everyone else's changes to the same branch without breaking the code? That's the discipline of continuous integration. So what I've done is I've created a little example here. Imagine we've got two developers, Jason 1 and Jason 2. It'd be great to have a team where it was just me and I could clone myself. Jason 1 and Jason 2, and we're working on code to run the sales for a CD warehouse. We're going to sell albums on compact disc. And I've picked up a user story called Buy a CD. So I've gone away and talked to the customer, and I've got some tests that we're passing now. And Jason number 2 picked up a user story called Search the Catalogue for searching for CDs by artist and title in our catalogue. Both of us now have got some code that we think is working. And what we'd like to do is we'd like to merge that code into a single code base. But when we got started, here's how this kind of goes. First of all, we need a code base to merge to. So Jason number 1, when we sort of started this project, what we did was we had a little talk about the architecture. We decided it was going to be .NET Core and stuff like that. And then Jason number 1 created a little dummy project that had the structure we were looking for with a dummy test in it. And he then created a GitHub repository and pushed that code to the GitHub repository, which Jason number 2 was then able to clone. So essentially now we're working on 2 copies of the same code base, the same GitHub project. So let's take a look at what's on GitHub first of all. So there it is. Let's just go back to the main page there, main code page. And there's really not a lot to it, basically. It's just an empty project. I've added a reference to NUnit, which we like to use for testing. Jason number 1 and Jason number 2 are both fans of NUnit. And all I've got in there is a dummy test that does nothing. There's no assertions in there at all, so it should always pass. The reason I've done that is because there's a kind of a second phase to this, if you like. It's not just about getting stuff into the repository. We also want to make sure that what's in the repository, that what's on the trunk branch, if you like, is working. That if the customer wanted to ship that, we could ship that. So what we do is we get what's called a corroborated build. So I've set this up at the back end here. Let's just take a look. Using a cloud-based build solution called Circle CI. And what Circle CI will do for this particular project is whenever someone pushes to the trunk branch in GitHub, it will be detected here. It will then launch a build. Let's take a look at what happens in the build. Very, very straightforward. They all often look a bit like this. So bit of technical gubbins here, but if Yak Shaving goes on, it spins up an environment using Docker for running .NET Core builds, sets all that up, checks out a copy of the code, builds it using .NET, and then at the end, very importantly, it runs our tests just to make sure they're all working on their machine, not on my machine. So we're seeing 2 things here. Number 1, is what's in our GitHub repository on the trunk, does it actually work? Could we ship it if we wanted to? And number two, we're ruling out the possibility that the only reason it was working on Jason 1's laptop or Jason 2's laptop is because of the specific local configuration of their machines. So we're ruling out potential configuration differences. So we call this sometimes a corroborated build. Let's see it work on someone else's machine. And every time someone pushes to the trunk branch, every time someone checks in their changes, we're going to get one of these builds. And the goal here is to keep, once it's up and running, as you'll see, getting started, there were a few missteps there, a few failed builds and a few problems. But once we get that continuous integration build up and running, our goal here now is to keep this green, because green theoretically means shippable. It's working. We could ship this if we wanted to. So we want to keep this green. Now, going beyond this, and we'll talk about this at the end of the video, a lot of developers kind of go, well, it's green, so I'm kind of done now. But actually, there's more stuff that needs to happen on the back end of this, potentially, that we can also talk about at the end. So we've got stuff in a GitHub repository. It's being built using Circle CI, a cloud-based solution here. And that means we're getting corroborated builds that are currently green, which means theoretically what we've got in our GitHub repository here works, and we would, as we add more functionality and make changes, we would like very much to keep it that way. Thank you. Because that means that what we've got is shippable. So let's take a look at the code that we've got here. So here's Jason 1's code. This is the tests for buying a CD. And I'm thinking I would like now to push this to the trunk branch. So how do I go about that? What's the discipline for not breaking that build, for not breaking what's in GitHub? Well, the most important thing, of course, is before we do anything. Now, you're going to say run the tests. I'm going to say no, there's a step before that. I first of all want to make sure, looking on the trunk branch, that I've got everyone else's changes. So when I'm about to run my test to make sure they're all passing. But before I do that, I want to just check that I have actually got everyone else's changes. Because when I push this, theoretically, what I've got on my desktop is going to be what ends up in GitHub. It's going to be the same code. That's what I'm testing here. So I need to make sure that I've got everyone else's code. So let's just check and see. Okay, I'm up to date. So there are no changes that need to be merged from other developers on the team. That's good news. Now that we've done that and we're thinking about committing this, before we commit, this is a very good habit to get into. Before we commit, we just make sure that it's building and all of our tests are passing. You'd be amazed how often people check in code that doesn't even compile. Just ask Linus Torvalds, he'll tell you all about it. Yeah, so we make sure that all of our tests are passing. In fact, I was looking at the camera while I did that, so take no one's word for it. Okay, so that's good. So first of all, we pull. If necessary, we merge other people's changes with our changes. Now, it is probably a good idea not to just do that when you feel like checking in, but actually just do that on a regular basis. Just pull it, merge the changes, and take a look and see what people have done. The more often you do that, the less time you'll be spending dealing with merge conflicts, and the less time you'll be spending clearing up problems and misunderstandings about the design and the architecture that could have been caught much earlier. Okay, so tests are running, that's all good. Now what we're going to do is I'm just going to make sure that everything's being tracked. Yep, okay. Now let's commit this. And what's the message here? So I've added test for by CD. Okay, so a nice clear message about what I've done here, so that not just other people can understand what I've done, but I can understand what I've done. If I need, for example, to revert to a previous version, it's very, very important that those versions are clearly labeled so they're easy to recognize exactly what you've done there. Okay, and there's a bunch of stuff going on here, so let's commit all of those. That's looking good. And what I'm going to do now is I'm going to push that to our trunk branch. Just a quick tip here. It's becoming, for very obvious and very good reasons, it's becoming unfashionable now, and I completely agree, to use the default name for the GitHub branch. But you can create a new branch and then set that as your default branch. So I've created another branch and called it trunk. I much prefer that word and always have. So let's push to the trunk. Fingers crossed that will go well. Could not need from the remote repository. Does not appear to be a Git repository. Oh, no, I've done it wrong there. It is early in the morning here. Yes. Push the origin to the trunk, please. Thank you. Having a little think, and there we go. So that code is now pushed, which means, as you can see, that's triggered a build on Circle CI. So we're going to make sure that what I've just pushed is actually working. Now, what happens if this build breaks? It's exciting, isn't it? If the build breaks, the implication of that is, number one, we can't ship that, but also nobody else can check in. Checking in on top of a broken build, essentially code that is broken, is a very, very bad idea. So you're now, if your build is broken, you're now blocking the rest of the team from checking in. So your continuous delivery pipeline, as we call it, is now blocked. It's all bunged up. So it's not just a problem for the person that's checking in, the person who broke the build. It's actually everybody's problem, because you now essentially you've bunged up the pipeline. Now that's a succeeding build. Now I'm super, super cautious here. So I'm just going to make sure that it actually is running the tests. Something I always watch for here. Because sometimes you think, oh, it's working, but in actual fact, it's not finding the tests. So it looks like it's passing. Okay, it's found 3 tests. It's working. I'm happy with that. So that is good news for JSON number 1. Now let's go over and talk to JSON number 2. So JSON number 2 also has changes that he'd like to check in. He's at a stage like he'd like to do a check-in here. And it's the same process essentially, but there's one little wrinkle here that I didn't mention. When JSON 1 checked in, there's a whole kind of transaction that goes on. If you think of your GitHub repository as a shared database, which is exactly what it is, and different developers working on clones of that code base think of them as database clients. When we're making changes to the data in a database, there is a risk that we'll get conflicting changes unless we take steps to prevent people essentially from changing the same code at the same time. That's the risk. Now, it's a fairly low risk on small teams and on large code bases. We're often working on disconnected stuff, but this is actually a very small code base and a very small team. And it's the start of the project. So we are actually going to be editing some of the same files. So there are some risks here that while JSON number 1 was checking in his changes, JSON number 2 over here checks in on top of him with conflicting changes, which, as we're going to see, would be actually what would have happened. So we need a simple way of making sure that doesn't happen, of essentially locking the repository or parts of the repository for the duration of that whole process, from the bit I'm about to do, which is pulling and merging, just making sure I've got everyone's changes. That's like a precondition for checking in. And then running the tests and making sure they pass, and then committing, and then pushing, and then waiting to see what happens to that corroborated build. And it's only when the build goes green that we say that that transaction is safely complete. That's the whole transaction, if you like. So on distributed teams, on large teams, on teams where people are kind of stepping over each other quite a lot in terms of the code they're working on, you might want to consider investing in some kind of what we call build token. A build token is some object. I like hats because you can wear them. Some object that looks out of place, that is instantly recognizable, can be seen from a distance. And if you're all working on video or whatever, maybe you need some kind of electronic version of one of these build tokens. And what it is it lives in its own place in the office, maybe on a shelf or on a table that doesn't belong to anyone, or in a box with build token written on it. And when you want to check in, the first thing you do is you go and get the build token. For example, you go and get the build hat. There's the build hat. You put on the build hat and you're now announcing to the rest of the team that you are checking in. And you can only check in if you've got the hat. So this is essentially the equivalent of a lock on a database, or a lock in multi-threaded code. It prevents other people from updating it at the same time. So you've now locked the repository. So now the transaction begins safely. So first of all, let's see what other people have changed. Now, this is going to be interesting because there are, as we take a scroll up and see the messages, Okay, there are potential to, let's first of all, let's do an add, and then we're going to have to do a commit, I think. So before we do this, git commit, let's go with added search catalog feature. Okay, so I've just done that commit. Now let's try git pull. Oh, I do enjoy git. Let's see. Okay, automatic merge failed. So now we have a conflict. Let's take a look at the conflict. I have a feeling I know where it is. Compactdisk.cs. Okay, so what's happened here is JSON number 1 has written functionality for a compact disk for buying a CD. JSON number 2 has added some fields and a little bit of functionality also to a class with the same name. So this actually was the result of some coordination, talking basically between JSON 1 and JSON 2. And we agreed that there is this class called compact disk. So we kind of agreed the name and where it lives to begin with. And okay, so what we're saying here is that here's the stuff that JSON number 2 added. That's my stuff. And let's clean this up. So we've got our private field here for payments. And there's that matches. So just a little bit of functionality there. And there's our constructor, which has been overwritten. You can see there we've got the artist and the title. We've got 2 constructors now. So it's kind of made it, and we don't want that. We want the same constructor. So what I'm going to do is I'm just going to fix that by adding those. And then we're going to add those. So a little bit of merging. So imagine that I was doing this maybe once a week. Imagine how big a job this would be. Okay, and now we need to fix some tests. Okay, so this needs a price and a quantity, I think. So let's give it a price of 10 and a stock level of 10. It doesn't really matter because we're not using those. And we need a payments thing. So let's make payments null because it's not actually being used. So we'll use a dummy here. And again here, it doesn't really, I mean, I can go 0, 0. No, it doesn't matter. So, okay, hopefully if we go back to our tests, and similar kind of thing here, we need an artist and title here. But again, it doesn't matter because we're not using them at the moment. So I'm kind of fixing the problem for both JSONs. And what else have we broken? Oh, there's a third test, isn't there? Yeah. Okay, now everything seems to be in shape. So let's go back and rerun all of our tests. So you see why it's important that while this process is going on, which can take a while sometimes, the risk is that JSON number 1 goes in and checks in more changes, and then that's really going to mess things up for me and for anyone else on the team. So by wearing the build token, by wearing the hat, and preventing that from happening, JSON number 1 can't do that. Okay, all our tests are passing, so I think we're good to go. So I fixed all those problems. Let's commit. What am I doing? And then merged JSON number 1's changes. Okay, and now let's push that to the trunk. And again, now that we've done that, lovely. let's immediately go and take a look. So you need to be kind of build aware as a developer. And a lot of teams use things called build monitors. Often this actually is literally a big monitor, a big TV that sits in the room that pulls off the status of builds from different branches, for example, or from different projects. So you're getting a heads up. You can sort of look up and see what the status of the build is. And I genuinely encourage you to be as build aware as you can be. So you should always be keeping one eye on the build monitor, or if it's on a web page on that, or if it's in your system tray or wherever you get that notification. Be build aware so that, number one, if the build is broken, you're aware of that, because that can be something the whole team needs to work on. But number two, you're then aware that people have made changes. So whenever I see a build succeed, I think, oh, at some point I should probably get those changes. I should pull those changes and take a look. So you need to be build aware. It is a form of communication among the team, and it's kind of like the heartbeat of the team in a way, in the sense that the frequency of builds often dictates the whole frequency of development and delivery. It's a bit like your metabolism, if you like, and we're going to talk about that when we talk about the testing pyramid later. So it's building, and we can see it's taking quite a long time. Now, we'll talk about that in the next video about the testing pyramid, when your builds take a long time and what we can do about that. So we're still waiting. And remember, while all this is happening, everybody else is blocked. So let's wait and see what happens. This is taking a long time. I am, of course, using the free version of Circle CI. I'm sure if you pay for it, they're faster than this. There we go, build success. So we've got another green build. We've got more code that is potentially shippable, but it hasn't been shipped. It's just in a shippable state. There's more to this delivery pipeline than just my desktop and GitHub and Circle CI. Once we've shown that it can build, the next part of the process is how does that actually get to the end users? And then there needs to be more of this process, more of this pipeline that extends beyond. For example, deploying the code into a staging area for customers to actually test. Some teams actually deploy automatically into production. So if it passes this build, every green build essentially automatically goes into production. Now, there might be all sorts of reasons why you would do that or why you wouldn't do that, and it will depend entirely on your situation. But here's the important thing. If the code is always shippable, and if the process of building and testing and deploying that code is completely automated, then you're in a position essentially to put the customer in the driving seat. It's entirely the customer's decision when to press the button and let those changes out into the real world. So it's a very, very, very important part of agile software development. I would say it's the centerpiece, if you like. It's the foundation of agile is continuous delivery. And in terms of technical practice, as we've seen, continuous integration, unit testing, and by implication test-driven development, that we're always taking those small steps, and refactoring, again, that we're taking those baby steps as we refactor the code, and we're continuously integrating while we do all of that. All of those roads are leading to continuous delivery. That's the whole point of it. They're all enabling practices. And in my personal opinion, you can keep the rest of Agile. You can keep your burn down charts and your user stories and your post-it notes and your stand-ups and your Kanbans. To me, the essence of Agile is continuous delivery, the ability to ship code whenever the customer wants it and to maintain the pace of that delivery for as long as they need. That's the essence of Agile as far as I'm concerned. And that's what Codecraft is all about. It's all, as you've seen in the rest of these videos, all of those roads are leading to this. They're leading to the ability to ship code whenever the customer wants it. Now, two last things we're going to talk about in this video. Thing number one. Oh, I should take the hat off. Jason number one is waiting now. Thing number one, he said with hat hair, is what happens if we break the build? Now, if we can fix it easily, we look at the build log and go, I see what's gone wrong there. It's a dependency thing, or I've forgot to put something in the configuration file, then just fix it and there you go. But if you can't see what the problem is, if you think this might take a while to fix, remember you are blocking the team, which means it's everybody's problem. Don't make it everyone's problem. Revert, roll it back, essentially. Roll that check-in back, take it back to the last working version, so that then you're unblocking it for everyone else, and then you can fix the problem in your own time. Don't make it the rest of the team's problem. There is only one delivery pipeline, and if you're getting in the way, you're the one blocking it, then the team is not going to be happy. Just surely if you are blocking all the drains on your street. The other thing I want to talk about very, very briefly is just this notion of branches, and particularly feature branches. So there are two reasons that teams give me for why they use feature branches, these long-lived developer branches. Reason number one is, usually the first reason is, we don't want to check in code for features that aren't ready yet. And I can understand that. It's like you don't want people driving over a bridge that's only half finished. So is there a way that we have all the benefits in terms of testing and communication and continuous delivery of doing trunk-based development, of doing this continuous integration, but without exposing users to features that aren't finished yet? And there is a mechanism called feature toggles, sometimes referred to as feature flags. This could be as simple, for example, as a text file, with just the names of features that are mapped onto actual code or mapped onto the user interface, or however you're doing this, that switch features, toggle features on and off. And you can even give the customer the power, essentially, to cut the ribbon on a feature when they want to and say, okay, that one's now ready, so I'll make that one live. So it can be quite a powerful mechanism. Under the cover, there are unfinished features. Just like often when you go to an unfinished building these days, because money, sometimes if they're doing building works inside a supermarket, they won't close the supermarket. They'll just section off the areas you're not supposed to go into, the dangerous areas. Similar kind of thing with feature flags or feature toggles. We're partitioning off features that aren't finished yet, so that menu item or that button doesn't appear until the customer says it's ready. The other reason that developers give me for using long-lived branches, feature branches, for example, is that specifically they're no good at this discipline. They're no good at the discipline of checking in frequently to the trunk without breaking the code. So that's why it's important to learn that discipline. Now, a lot of developers don't use build tokens, and they get by fine. They break the build occasionally, but they're not working so close together, if you like, in such close quarters to each other in terms of the code, that they're constantly breaking it. But if you find that your builds are breaking often, then you really do need to take a look at some way of preventing people from checking in on top of each other, because that can be a source of quite a lot of pain. So there you go. That's continuous integration and continuous delivery. As far as I'm concerned, they are agile software development. They are the mechanism that makes it work. And the technical practices of agile are all roads that lead to continuous integration and continuous delivery. And the management practices of agile are not possible unless you're doing continuous delivery. So if you think you're agile because you've got a Kanban board, or because you're doing Scrum, but you're not continuously delivering, that is to say that you're not frequently checking in code that works to a trunk branch that could be automatically built, tested, and released to end users, then you ain't doing agile. I don't know what you're doing, but it's not agile. So there you go. That's CI and CD. It's important stuff. In the next video, we're going to talk about a very, very important topic, something that I've seen kill many businesses, relating to continuous integration and continuous delivery. Until then, hope you're staying safe. If you're interested in following this channel, then ring the bell for notifications or subscribe. Lots more videos to come for C# developers and other languages.